let's review some quadratics, some vertex problems, some solving for a quadratic. Let's review some polynomial, find the zeros of polynomials. Let's review some things about rational functions, like asymptotes and such. So here we go. We want to solve this bad boy. Now, sometimes it says to solve by a specific method, and I think this says solve by completing the square. But you can always solve these using the quadratic formula. It doesn't matter what, it will always work. The quadratic formula is, as long as it says equals 0, and it's x squared is the highest number, the highest power. The quadratic formula always works. But it says complete by using the square. I'll by completing the square. So let's do it by completing the square. So what you want to do is we talked a little bit about this on the circles. So you start off, you take half that number. All right, and I'm going to go ahead and move the 40 over to that side. Now here's the thing. You've got, if you multiplied this out, you'd have a 4 up here. Well, there wasn't a 4 up here. So I've added 4 to this side, but not this side. So I'm going to add 4 to this side. When I do that, that's pretty much what I did with the circles. Remember, I took half that number, took half of this, put it there, squared that number, and put it over here. And in this case, I did one more step where I'll go ahead and move the 40 over. That's what I'm going to do anyway. So, and again, you can check out the link of completing the square. So now I've got this. The whole point of completing the square, it makes it a little bit easier because you're going to take a square root now. And when you take a square root, it's automatically plus minus. And you're taking the square root of a negative 36. So it's not just 6, it's 6i. So we actually have a non-real answer here. And then we're going to subtract 2. So x equals negative 2 plus or minus 6i. So we got two answers. One's with a plus, one's with a minus. Right? Negative 2 plus 6i. Negative 2 minus 6i. Now, if I did that with the quadratic formula, I should get the same answers. So the a was 1, the b was 4, the c was 40. I'll plug my values in here. Okay, clean this up a bit. Negative 144 over 2. Negative 4 plus minus, let's see, the square root of 144, it's 12. And it's negative, so you say I for 2. Now this gets divided by 2, and then this part gets divided by 2. They both get divided by 2. If they both don't get divided by 2, you don't simplify, but they both do. 4 divided by 2, negative 4 divided by 2, 12 divided by 2. Well, there you go. It's the same thing. So you can complete the square, you can use the quadratic formula, either way. Try it again. We'll complete the square again. And to me, it's a little bit easier to do it completing the square than it is to go through all that with the quadratic formula. So remember what I did. I'm going to move the 8 over. All right, I'll take half the 10. Technically, I've got a 25 in here, 5 squared. So I'm going to add 25 over here. Would that be what, 17? So, it wouldn't be negative, positive. So take a square root, get rid of the power of 2. It's automatically plus minus. Square root of 17 doesn't simplify. So it's just the square root of 17. Take away 5. 2 answers, negative 5 plus square root of 17, negative 5 minus square root of 17. It's a 5, not an 8. And you can work through it with the quadratic formula. It'll work the same way. You'll get the same answers. Vertex. To find the vertex of a quadratic. Remember what a vertex is. It's the very lowest point. It's that very lowest point. Negative b over 2a will find the x value. Find the x value of a, I should say x value, the x coordinate of the vertex. If that point right there, it'll find the x coordinate for the point right there. All right, so the a value is 3. The b value is 12, like you're doing the quadratic formula. That's the same a and b. So negative 12 over 2 times 3 be negative 12 over 6. Negative 2 is the x coordinate of the vertex. So to find the other value, you just plug it back in to get the y value. It works with anything to find a point. You just take your value of x and plug it in. So 3 parentheses negative 2 squared plus 12 times negative 2 plus 8. So it'll be 3 times 4 plus a negative 24 plus 8. So it's 12 minus 24 plus 8. That's 6, 14, be 16, negative 4. Negative 12 plus 8, yeah, negative 4. So our vertex is at negative 2, comma, negative 4. Negative b over 2a, and you plug it back in. A lot of formula sheets will do this. What that means is a point, because it's a vertex. There's how you find the x-coordinate, and then you plug it back in. That's what the function notation means. You plug it back into the function. You plug it back in for x to get the y-coordinate. All right, so we got a, might be hard to see here. It's a word problem. It says a projectile is thrown upward. I'm doing number 4 here. Projectile is thrown upward so that the distance above the ground after t seconds is this function, given by this function. How many seconds after how many seconds does it reach its maximum height? Maximum. So when it says maximum, you're talking about vertex. So in this case, if I do negative b over 2a, it will tell me the t value of the vertex. T, the time, the x. It's the x value, what we just did, but it's the t. It'll tell me the t value here, the maximum. So it'll tell me the time to get the maximum height. So negative b, negative 570. There is no c value here. 2 times a, negative 16. 570 over 32. So let's see what that be. 570 divided by 32. 17.8125. And I guess we could just round that up to 18 seconds. Now, if you want to know what the maximum height was, if you actually wanted to know that how many feet it was, well, you take that 18, or this number right here, and you plug it back in for t, and it would tell you the maximum height. John owns a hot dog stand. All right, selling some hot dogs here, and it says his profit is represented by this function, p of x being profit, x being the number of hot dogs sold. That's what x represents. What's the most he can earn? He can earn most. Vertex. So, what's the vertex here? Negative b over 2a. Be negative 10 over 2 times negative 1. The a value is a negative 1. 5. Does that mean the most he can earn is 5? No. What you're doing is you're finding the maximum x value. The x's in this question represented hot dogs, remember? I just read that. It says x, the number of hot dogs sold. He needs to sell 5 hot dogs. So if he sells 5 hot dogs, we need to plug that back in. And we'll actually get the profit he made. $58. $58 is the maximum profit. Now, I guess the reasoning behind these profit functions. This is a ridiculous question. I mean, it's John owns a hot dog stand. He's not gonna be doing this for a hot dog. He might. I don't know, but it seems ridiculous. The idea is that his profits, the more he sells hot dogs, the less profit he gets, and that doesn't seem right. And it doesn't seem right for a hot dog stand. It just doesn't seem right. Now, it makes more sense if you're in a factory. So, for instance, let's say you're selling trucks. You're selling Ford F-150s, Toyota Corollas, or something like that. All right, this is the number of cars you sell, or the cars you can make. Well, if you just make one, if you just sell one car, you're not going to make much profit. If you just sell 2 cars, you're going to make a little bit more profit. If you sell 3 cars, a little more profit. 4 cars, 5 cars, 6, 7. The more cars you sell, the more profits you make. But here's the thing. At a certain point, you can't handle selling a whole bunch of cars. So this is the car sold, and this is going to be your money, right? Your profit. And think about it. If the more cars you sell, the more people you got to hire, the more cars you need to produce. The more cars you produce, it might cost more to produce them because your factory is overloaded. And what happens is your profits actually start to go down the more you sell. That's the idea behind it. All right. So some things, I don't know if a hot dog stand really counts as this. It's a pretty bad question, but it's the same idea that the more you sell doesn't mean the more you make, because you run up in profits, you run up into problems of success, so to speak. Maybe John has sells so many hot dogs, he can only make so many hot dogs an hour. Maybe 5 is the most he can make and sell and keep his customers happy with the quality of his hot dogs. I don't know. But the idea is that the more you sell, the less you can make, and that's actually is an idea behind it. That's a business principle, I suppose. Right? That seems all right. All right, enough of me and my soapbox here. Let's get back to some polynomials now. So you want to find a polynomial, and it says here it's of the lowest degree. So you want the lowest degree you can. It has to have rational coefficients, and given these zeros. So you're given these 2 zeros, and you got to find the polynomial that goes with that. Well, here's the idea. Remember a second ago where we came up with this I business? The only way you could have come up with an answer with an I in it is if you took the square root of a negative number. And when you take a square root, you automatically have a plus minus. You have to. So the idea here is that if I told you that this was one of the solutions, -2 plus 6i, then automatically you should know that -2 minus 6i was another solution to that problem, because they're like inseparable twins, so to speak. All right, they're inseparable cousins. So if 2 plus I is a 0, that automatically means that 2 minus I was also a 0. So you know the zeros, right? So there's that. This has to be the least amount of zeros here. Now, if you know the zeros, then we can put this in factored form. There's 3 of them. It's automatically x minus on all of them. That's how you do factored form. And here you put the 0 in right here, 4. You put this 0 in, and you put this 0 in. Now that's in factored form. And sometimes you can plug that into your homework. Sometimes you can your homework system, MyMathLab or Hawks or whatever you're using, WebAssign. But we want to multiply this all out, because I think what I'm going to ask of you, it's all multiplied out. So we want to multiply this all out. So here's what you do. You multiply the I business first, and when you multiply these 2 guys together first, and the i's will disappear. It'll happen because they're conjugates of each other. So first off, I'm going to simplify these 2 guys individually. So there's a negative in front of this, and you distribute a -1. And there's a -1 in front of that, so you distribute a -1. Okay, now I distribute an x to all 3 of these. X times x, -2 times x, I times x. Now I distribute a negative 2 to all these. So negative 2x. Negative 2 times negative 2 is positive 4. Negative 2 times positive I is a negative 2i. Now I distribute a negative I to all three of these. Negative ix. Positive 2i. I squared, it'd be negative I squared. Now you clean it up a bit. I've got an ix here. Oh, let's see, x squared minus 4x. So I've used that, and I use those two. Here's an ix and a negative ix. They cancel. You've got a positive 4. Use that. Negative 2i, positive 2i cancel. And then you're left with a negative I squared. I squared is automatically a negative 1. Anywhere you see an I squared, it's equal to a negative 1. And we see an I squared right here. So that's going to turn into a negative 1. And two negatives together make a plus. So 4 plus 1. There's that part. So what we've done is multiplied these two guys together. And we have gotten that to be x squared minus 4x plus 5. So we need to multiply this guy and this guy together now. So let's multiply that together now. X minus 4 times x squared minus 4x plus 5. Distribute an x to all this. So distribute x times that, distribute x times that, stuff like that. Distribute all three pieces, a negative 4 to all three pieces there. Okay, and these two guys go together. That's x cubed. I'll do that for. And then 15 and 16, 5 and 16 give you a positive 21 minus 20. And there's your polynomial that gives you those three zeros. Man, that was fun. Find the other zeros of this guy right here. And it has to be, it's given you that negative 2i is a 0. So, what can you do then? Well, if negative 2i is a 0, then if negative 2i is a 0, then positive 2i is also a 0. Okay. Now we just need to find the other zeros, because you're going to have 4 zeros at most, and you need to account for all 4 of them. So here's a long way of doing it. You know these two guys. So I'm going to put them in the factored form. These are two factors of this, right? X minus a negative 2i, x minus 2i. Two negatives make a positive. So x plus 2i times x minus 2i. Now if I multiply those together, okay, so I distribute the x and distribute the 2i. These two guys would cancel. You remember what this I squared is? It's actually a negative 1. And negative 4 times a negative 1 is a positive 4. X squared plus 4 is also a factor of this. So if we use x squared plus 4 and use long division into this, and there's a gap here, there's no x cubed, so I'm going to put me a gap, a 0 x cubed in. There's no x, so I'm going to put me a gap in. I use long division, it'll tell me, it'll help me factor this. So how you turn x squared into x to the fourth? It would use it x squared. X squared times x squared is x to the fourth. X squared times 4 is 4x squared. Remember, you're subtracting here. So negative 12, that cancels the 0. I'm not going to bring a 0 down. Negative 12 minus 4 is a negative 16. I'll go ahead and bring down my stop gaps here and the negative 64. How do you turn a negative 16x squared into an x squared? Negative 16. And if you subtract these, cancels, 0. That's what you're supposed to get, right? It's supposed to be a factor, so you're supposed to get a 0 out of it. So now what you've done is you found another factor. This factor gives you the 2i and the negative 2i. What would this factor give you? If we add 16 to both sides and take a square root, plus or minus 4. So the other two zeros are positive 4 and negative 4. So all the zeros, 2i, negative 2i, 4, and negative 4. That's the long way of doing the question. You can do synthetic division with the i's if you want to do that, if you're good with that. Most people aren't. So you multiply these two guys together to get this, use long division to get this, divide it out to get that, then you set that equal to 0. Now, if you graph this thing, you can find the other two zeros. I'll just let you know. I mean, if you haven't figured that one out already, you could have found 4 and negative 4 from the graph. So, to each their own. So that's how you can find the other ones. Find all the possible rational zeros. Okay, so possible rational zeros. So you take all the factors of the last number. Don't worry about the negative business. What's all the factors of 8? 1 times 8, 2 times 4. And that's it. And then you take all the factors of the front number. What are all the factors of the front number? 1 times 2, and that's it. So divide all of the factors of the last number by all the factors of the front number. I didn't use any math vocabulary at all. So make sure you take you must use the term back here, the coefficient of the x to the 0 power term. Use the last number. Make sure the front number is the actual front number. Make sure all the powers are listed in descending order, basically. So make sure it's in that form, and then take the last number, the front number. All right, find their factors. All of these guys at the back, factors of the back, get divided by all of these. So all 4 of these get divided by 1. All 4 of these get divided by 2. So if you divide anything by 1, it's itself. Then all these get divided by 2. Let's see. 1/2. 2 over 2 is 1. I've already got that. 4 over 2 is 2. I already got that. 8 divided by 2 is 4. So I already got that. So we got these numbers right here. Now, this is what you do to compensate for the signs. You just say plus or minus. That compensates for the signs. I like to just write it as one set. I say plus or minus and a squiggly. And I don't have to write plus or minus in front of all the numbers. But either way. Take all the factors of the back divided by all the factors of the front. That's how you find the possible rational zeros. So these are not the zeros. None of these might be a 0. But this is the only possible rational zeros. This is the only numbers that you could use. There could be square roots or i's that don't show up that are zeros, but these are the possible zeros. Alright, find all the zeros of this guy. Factor into linear factors. So we want to find the zeros of this guy. So I'm going to take all the factors of the last number. 1 and 18, 2 and 9, 3 and 6, 4, 5, 6 and 3. Alright, so these numbers flip, so I know I'm done. So there's all the factors of 18, and the front number is 1. So good. Here's the possibles. 1, 2, 3, 6, 9, 18. Plus or minus. That could this is the possible zeros I've got so far. So I'm gonna graph this guy and see if any of these hit. Right? Because a zero is an x-intercept, right? So let's graph this bad boy. Alright. Here's one of them at -2. And I've got another. I need to figure out if it's 18. I don't see any. I can't see 18 on here, so my calculator can just go over. So 18 doesn't work. Or you can go to your table. On my calculator, if I go to the table, I can just ask it. 18. Oh, that's not a zero. -18. That's not a zero. So the only thing I find is -2. So let's do -2 on this guy using synthetic division. To bring down the 1, multiply, multiply, multiply. Alright, so if I do this, this was on x cubed. So when I do synthetic division, it drops it down a degree. So I wind up with x squared plus, plus 9. That's the other factor. So I factored this thing out to x minus a -2 times x squared plus 9. Well, x plus 2, x squared plus 9. So if I set that equal to 0, I'll find the other zeros. Subtract a 9. Oh, that's why I'm not seeing it. That's why I'm not seeing it. If I take a square root of -9, it's a 3 plus or minus 3i. That's why I didn't see it on the calculator. They were invisible. They're not invisible, they're imaginary. So all the zeros were, let's see, -2, 3, and 3i and -3i. There's the zeros. In factored form would have been x plus 2, x minus 3i, x plus 3i. There's my factored form. It has to be linear factors. I didn't have it in linear factor down here. It had to be linear factors. Alright, enough about polynomials. Man, that's a long video. Sorry. Okay, find the horizontal asymptote of, and these are all rational functions, the horizontal asymptote. So what you do is you compare the degree. So the degree of the bottom is bigger than the top. And when that happens, it's automatically y equals 0. That's what I remember that one because it's the bottom's bigger. So I call that my fat bottom girl. Because if you know what the Queen song, Fat Bottom Girls make the rock and roll go round. And I see that's so round right there. So y equals 0. I don't know, that's stupid. Follow the link. I'm sure there's a YouTube video somewhere of that song if you've never heard it before. Or if you like the song, follow it now, take a break, listen to it. Whatever. If the degrees are equal, like in this case, it's automatically y equals, and you get a fraction, and you take these two coefficients, 2 over 1. So y equals 2. That is your horizontal asymptote there. If the top is bigger, there is no horizontal asymptote. But there is an oblique in this case. Okay, there is no horizontal. if the top is bigger. But now, if the top is bigger by 1, it's an oblique asymptote. It's not a horizontal asymptote, it's an oblique asymptote. And to find an oblique asymptote, you just do a quick and dirty division. So how you turn an x into x squared, an x. And then you get positive 11. Remainder doesn't matter here. Once you get a linear, once you get these two terms on top, then you're done. It has to be linear. You say y equals x plus 11. That's your oblique asymptote, if the top is bigger by 1. And then you've got a vertical asymptote. In a vertical asymptote, you set the bottom equal to 0. That's your vertical asymptote. Make sure that that does not zero at the top. Make sure that does not zero at the top. 6 plus 2 is 8, so you're fine. This is a vertical asymptote. If it does zero at the top, then it's not an asymptote, it's a hole in the graph. But there's your vertical asymptote, x equals 6. Sorry for the long video. If you got any questions, feel free to ask.